Welcome back. I've got the MVT ignition installed on my engine now, but there's a little bit that I need to take care of before I'm ready to go bolting the engine back into the scooter. The MVT ignition includes a CDI as well as an ignition coil. The only issues there are that they both mount in different ways than what I have on the scooter right now, so I'm going to begin by working on those things. This is mounted to a plate on my frame, and I'm hoping that if I remove that, it'll make an easy mount for the new MVT ignition coil. Unfortunately, my mounting holes here aren't going to line up because the spacing's way too wide, but I think what I'm going to do is just try to reuse this bolt hole over here and make a new one over here, and it should be simple enough to mount this coil. Got some touch-up paint left over from a car that we don't have anymore. Just gonna make sure this doesn't rust. Put a little bit of that on there. I don't feel like actually trying to paint the frame right now. Touch up these other spots also. While I'm waiting for the paint to dry on the coil mount, I'm going to work on the CDI. Shouldn't take too much. You can see this is a bolt-on, and this one has no place to bolt it on, unfortunately. So I'll probably just take this off and then zip tie this one to the frame. I've also got to switch my regulator rectifier out because I have this Trail Tech, I think it's like an RR150, but it's a full wave regulator rectifier because I had floated the ground and converted my stock Stator over to full wave. And that's not going to work with the half wave, more standard setup from the MVT. So I've got to take this off. I've got a Yamaha Zuma regulator rectifier here, and obviously that's not going to use the same bolt pattern, so I just want to take care of that while I'm at it. That way any paint I put on holes I drill can dry while the coil mount's drying. I'll probably end up having to take this box out. Well, this thing barely fits. I can't actually fit it directly sideways because it's too wide with these mounts out here. I can kind of fit it like that, a little bit diagonal. I can't put it straight up and down because the connector would run right into the frame. So I'm pretty much stuck with that. And I'm not even sure if I have enough room to run a nut and bolt on the bottom. But regardless, this should work. It looks like that should work. So I'm going to go ahead and take this back off, and then I can paint the spots where I drilled through and let everything dry. The paint's dry enough on the frame now that I can mount the coil, but before I do, I want to straighten up some wiring issues. So this is the MVT coil, and it uses a really simple single connection. It's just got this 1/4 inch quick disconnect or spade terminal, whatever you'd call it. And then the ground, that's for the coil positive. And then for the ground wire, you can see it comes out of the coil, and they just attach it right here to the frame. So they rely on mounting the coil here by this frame to a good ground here, like on the frame of your scooter. I do have 2 wires coming out of my harness, the coil positive and a ground. So what I'm going to do, I'll have to extend the coil positive wire a bit because it's not going to reach. And the ground wire, I'm just going to put a ring terminal on there, and I'll mount the ground wire with a ring terminal under one of the bolts to mount the coil. So that way it'll have a good ground being bolted right to the frame with the ground from the wiring harness as well. And I'm also going to go ahead and take off my spark plug wire. I put it on as a demonstration in my last video, but this is way long for where my coil is going to be. So I'm going to take that off for now, and I'll cut it to length later and reinstall it. Now I'm going to change the connections for the CDI around a little bit because I like using sealed connections pretty much anywhere I can on the scooter. And this is where the CDI would actually connect into my wiring harness, and this is a 3-prong weather pack connector. So it will correspond with the orange wire here, that's coil wire, and the ground wire in this one, as well as the kill signal wire here. All 3 of those wires will be connecting here on the harness. And then these 2 wires, the red and black and the green and yellow, connect to my stator, and I will probably also convert these over to sealed weather pack connections. Now I've got terminals on each wire coming from my CDI that will correspond with the wire connector coming out of my harness. I just need to know exactly which wire to connect them to when I put them into the housing. This is where wiring diagrams come in handy. My scooter, as I've told you before, I built the harness from scratch myself, and some of the stuff has changed around. But when I did that, I actually made a detailed wiring harness of all the connections on my scooter so that I'd have it for future reference. And things like that pay off right now. If your scooter is stock or near stock, you can probably just look up a service manual or try to find an individual wiring diagram, and that may work. And also, before I jumped into any of this, I made up a diagram of basically what I expected to do to connect this MVT setup to my scooter. And I will put this up on the screen clearer than this, and I'll also try to put a link in the description so you can get it if you want. This is more universal. This isn't custom tailored just to my scooter, but it shows the basic wiring, I think, clearer than MVT shows it, and it also shows the Yamaha regulator that I'll be using, exactly how that could be connected. I find it a whole lot easier if I can figure that stuff out beforehand and be prepared, versus getting to here and then having to go run in and try to find wiring diagrams and such. Now I've got the nice sealed connectors on my CDI. I'm going to go ahead and plug that into the large one on my frame coming out of the harness. And now I've just got to deal with the engine to give it matching connectors for these. Both of those are finished, and I just wanted to point out one thing that's really helpful when you're doing any kind of wiring. If you've got 2 of the same style of connectors, what I like to do, you'll see here, I have a female connector on this wire, and I have a male connector on this wire, and then obviously this one will plug into a female on the harness, and this one will plug into a male. And that way you can't get it mixed up if you are quickly trying to connect something They only fit one way. You can't connect these the wrong way. Now I need to work on my regulator rectifier setup. And this uses a totally different connection than the rest of my system. What I've got here is it's a 250 series 4-pin connector. I got it from Corsa Technic, and there's the part number, just in case that comes in handy for anybody else. And you can get the connector housing here, and it comes with the actual terminals. So I'm going to set that up to work with my Yamaha regulator rectifier. And then coming out of the frame, this is where I get the line to the battery and the ground. That's a weather pack, so I'll kind of jump it into there, as well as set something up to connect it to the charging and lighting wires coming out of my stator. Then I'm going to have a bunch of extra set up, because this Trailtech regulator rectifier that I was using, the full wave unit, it also has a relay function in there that I used for my headlights, because I don't want my headlight and taillight, etc., powered directly from my ignition switch. It may be able to handle that, but I would just feel more comfortable having a relay. This actually did that function all in one, so it created less wiring. Unfortunately, I don't know of a half-wave unit that would do the same thing. I already checked Trailtech and they didn't make any, that's why I went with this. So now I've also got to set up a separate relay back here somewhere to do that function. But the good news is, at least with my wiring back here, I've got a pin going right up to my fuse block that then goes to my headlight switch to power my headlight, so I can just tap into that part here. But I'll have to have a power ground and a switching source to make the relay operational. Just in case anyone else decides to set up a scooter like this, as part of my wiring diagram that I showed you earlier for the MVT, I also included a pinout so you can tell exactly where each wire needs to go in the connector to the rectifier regulator, and I have the part number of this regulator rectifier on there as well. If you watch the MVT installation video, this is basically the same process as what I showed you with the connectors on there. These have little pins on the back of the terminal. That pin needs to go where you can see kind of the provision for it down there at the bottom of each of these holes. And double check, make sure you're putting it in the right spot. And then you'll just push in until you hear that click, and then it should be locked in. Oh, and one thing I didn't mention before, this isn't the exact connector for this. I'm not exactly sure where to get the connector that matches this perfectly, because neither one of these has a locking tab on here. You would need a locking tab on here to interact with this, and I don't know where to get the connectors that have that, but these will fit pretty snug to where I don't think it's a hazard that they're going to come apart. Although you could try to use a zip tie around here or something like that to make sure it didn't come out if you were worried about it. But really shouldn't go anywhere. Alright, so I've spared you all the details of the wiring, because I've pretty much just been sitting here putting connectors on things and running wires around for the last probably couple of hours. But you can see, hopefully, I've got my sort of jumper set up finished for the regulator rectifier. I've got all the wires I need coming off of there. This is the one that goes into the harness from the frame. This will attach to the engine, and then this will attach to my relay for the headlights. I've also put a weather pack connector on that. I've got all that stuff pretty much set up, and more or less I just need to start bolting things together and connecting connectors. Now I just want to make sure that my headlight will come on when the key is on, and that I can turn it off with the key as well. Looks good. Tail light's working. Shouldn't have messed with any of that. I'll just check my signals as well. Now I'm going to try to set up the timing indicator that I made a couple of videos ago. And I think I'm going to use a degree wheel to try and help me with that. I could do it without, but I want to use the degree wheel to kind of double check myself. And I also think I'm going to use this as an opportunity to make a video about setting up a degree wheel with a dial indicator. Because I've done one all about a degree wheel and finding true top dead center using a piston stop, which is a really common method in the past. But I've never done it with a dial indicator, so I kind of want to do that while I'm at it. So for that reason, I won't show you in this video all the setup of the degree wheel. I'll probably make a separate video about that. I showed full detail of setting this thing up in the video that I made about making it. So if you want more details, please check that out. But basically, I just made these spacers, use longer bolts, and I'll replace the bolts in the mounting plate one at a time. That way nothing should move, and that'll allow me to set this up on here without changing anything. The size of this head of the bolt here is actually too large, and it's running right into my stator. And I don't want to tear up the stator, so what I'm going to do is I'm going to go ahead and put that back in. And then I'm going to try loosening the bolts on the stator itself and see if that gives me enough wiggle room that I can get that by there. Unfortunately, that means that I'll have to reset my timing here, my MVT rotor, readjust that back to the spec. Not really a big deal though. And while these are out, I think I'm going to see if I can just set that in the lathe and take a small bit off of the outside diameter so it's not an issue in the future. I cut these down from 9.9 to 8.5 millimeter outside diameter. Still looks like they've got enough meat left that it shouldn't be a problem with breaking them or anything, trying to tighten them. And before I move on, I'm just going to make sure that these will actually install without having to loosen anything up. I've got my stator tightened back down just to make sure they slide right by there now. Looks good on the top one so far. Yeah, so that looks good now. At this point, I've got the rotor set up again for the 0.35 millimeters before top dead center spec, and I decided not to put my timing indicator back on just yet. The reason is there was some discussion on the forum and as well on YouTube, and what that was about was how to set up the inner rotor to those timing specs to whatever millimeters before top dead center, and there was some talk that it should be done with the dial indicator set up and zeroed on true top dead center versus set up and zeroed just at the top of the piston's travel. So what the difference is the piston gets to the top of the bore and it will actually dwell there because of the way the connecting rod moves below it. It actually dwells at top dead center for a varying amount of degrees. So in my case, I've actually checked it in another video, and it dwells there for about 3 degrees at top dead center, where my dial indicator says 0.00 millimeters, but the crank angle, the degrees of duration on my degree wheel will actually change about 3 degrees in total. So about 1.5 degrees on either side of true top dead center. And true top dead center is something you need to find using a degree wheel or using something like that, where you can find exactly where the dead center point is at the top of the travel, not just the measurement, but as far as in degrees of crankshaft rotation. So some people say that it would be better and more accurate if you set up your dial indicator at true top dead center, and it seems that the majority of people do like I showed you in my video. They just zero their dial indicator at top dead center and call that close enough. So what I'm going to do is I'm going to move this engine over to my scooter workbench so that I can get all the way around it, and I'm going to set up 2 additional cameras, so hopefully I'll be able to show you the degree wheel, my dial indicator, as well as the markings on my rotor. Now you should be looking at 3 different views. You should be able to see my dial indicator, the markings on my stator and rotor, as well as the timing pointer here. Purpose of this is I want you to be able to see all three of these so you can see exactly what happens, all tied together, synced together, as I change timing a little bit. So right now, my degree wheel is right on true top dead center. I've already set that up as accurately as I can possibly get it to true top dead center. So I'm going to make sure, even though this is on 0, I'm going to hit 0 one more time on my dial indicator. So I know it's definitely zeroed at true top dead center. And then I'm going to verify that these markings on the rotor and the stator will align at 0.35 before top dead center, 0.35 millimeters before top dead center, as the specification says. Okay, so that's 0.35 before top dead center, and it looks to me that everything is lined up. And what I'm doing is I'm actually looking in the viewfinder or the screen on my camera, because I found the most accurate way to do this is to keep a very steady point of view, because any movement around here will make any of these timing figures, aside from the dial indicator, look a little bit different. So I've tried to just do this based on looking at my screen on the camera that's looking right at the rotor and stator here. Alright, now I'm going to do it a little different. First, if I can keep my hand out of the way enough, I'll try to show you that I can actually move this away from top dead center and still have the dial indicator show that it's on 0. So there I'm 1 or 2 degrees off of top dead center. Dial indicator shows 0. And again, I get 1 or 2 degrees off of top dead center, and the dial indicator stays on 0. So what I'm going to do is just to set this, as soon as I see 0 again, I'm going to 0 my indicator. That way I'm kind of as far off as I can reasonably get from 0 here, or from true top dead center. Alright, so that's 0 now. Now what I want to do is align my markings on the stator and rotor and find out what it shows on the degree wheel and the dial indicator. Or I can go to 0.35 before top dead center and see what that shows. So that looks pretty well aligned to me, and I am at 0.35 before top dead center. You should notice a calculated crank angle in the specs at the bottom of the screen. And the way I came up with that was I used a calculator at, I believe it was torquesoft.net, that takes into account the stroke length as well as the connecting rod length, and then you can enter the distance of the piston from top dead center, which I entered 0.35 millimeters, just like my setting. According to that, I should be at 9.12 degrees before top dead center when my piston is at 0.35 millimeters before top dead center. What I actually saw when I set the dial indicator, I zeroed it at true top dead center, was 9.25 degrees roughly. And I think you would have to have a much larger degree wheel to be able to see that sort of discrepancy. That would be 0.13 degree difference. I think you'd have to have a larger dial indicator than I'm using, and you'd have to be incredibly careful to see that kind of difference. But I was just a tiny bit off there. Then when I set my dial indicator at 0 somewhere in the dwell period around top dead center, but not on true top dead center, and it looked to me like maybe I was around a degree off, what I saw was 9.75 degrees before top dead center, and again, that's roughly. So it appears to me that there's about a half a millimeter or a half a degree discrepancy, depending on how I set it. Now I do have around 3 degrees of dwell at top dead center where my dial indicator says 0, so that's a degree and a half on either side. I would think worst case scenario there would then be that I could be about a degree and a half off worst case scenario. And if you had a different stroke length or a different connecting rod length, then you could be a little further off or maybe a little less off depending on the exact setup. So I would say you know, let's just say maybe you're anywhere from 0 to 2 degrees off, depending on exactly what your setup is in sort of the worst case scenario. So now the question is, does that even matter? In my opinion, the real world answer to that is no. It doesn't really matter if you're off something like 1 to 2 degrees with your setup of an interrotor system. Now, I tend to be someone that is detail oriented, and I can often get lost in details that don't matter, and I'm trying not to do that here. So here's why I'm saying that that detail maybe isn't terribly important. I do think you should get as close as you can roughly, but if it were off that much, I don't think it would really make a whole lot of difference, because how close are you actually going to be to that spec? First off, as I told you, the reason I use cameras is because my viewing angle to these markings on the stator and the rotor really changed how I saw them as aligned. So if I was standing over here looking at it from this height, it looks like it's aligned one way, and then if I move down here and try to get level with it, it looks a little different. If I move over here, it looks a little different. So you would have to be so consistent just on exactly where you are and trying to get right straight on with that alone would probably lead to 1, 2, 3 degrees of variation for most of us, unless you're going to set up a camera like I did or something right in front of it that you can see it, which wouldn't be a bad idea if you really want to be as precise as possible if you have a spec in mind. So there's stuff like that. Another thing, how much difference does it make if we're on this manufacturer supplied timing spec? MVT says a range of 0.35 to 0.4 millimeters before top dead center for this particular kit with their supplied CDI. What they don't say, they say things about stroke length, stroker crank versus a standard crank, or they actually say in some cases things about displacement. What you don't hear is any specific specs for specific stroke length. They don't say if you've got a 39.2 millimeter stroke right here, if you have a 43 or 42 millimeter stroke, put them in these sections, a 45 millimeter stroke goes here, etc. They don't go into that detail. They do not mention anything about connecting rod length, which can affect the dwell and exactly how the piston moves and change this as well. Being an ignition timing spec, ultimately, what they also don't say is things about compression ratio, whether it's effective compression ratio, corrected, uncorrected, whatever, or what pipe you're using, what cylinder you're using, port durations, the RPM you intend to use the engine at, what kind of fuel you're using. They don't go into any of these details, altitude, none of that stuff. They don't mention any of that. So that leads me to believe, as well as people that I've discussed this with, that basically this is a ballpark kind of figure in the first place. This is a figure that they hope is close for you. They're hoping it's close enough that your engine runs pretty well, and that the first time you use the scooter or when you're using the scooter, you don't blow the engine apart and scatter parts everywhere. It's a kind of ballpark figure. It is absolutely not going to be the best spec for everyone that uses this ignition system. I don't know how much of that is just lack of effort. It could be, it would be a lot of work to try and figure out exactly what ignition specs would work best for everyone that buys your ignition system with each different cylinder, etc. This may be kind of a mean or median average, basically, of what they think works for most people using this. It could be a liability issue. Maybe they would rather not say use this exact timing and then it wasn't that safe and you blew your cylinder up, melted a piston, and then you blame them or something. I don't really know what the case is there, but basically my take is if you want to set it up at true top dead center, that's fine, but if you don't want to bother with setting a degree wheel up and just set 0.00 millimeters, just zero out your dial indicator on top dead center, I think you're probably going to be close enough. And what I think you should really do if you actually want to see accurate timing specifications is you should set up a timing light on your engine once it's done. That way you can see where the timing actually is, the ignition timing, exactly where it's set. With that said, I'm not going to try and bore you with this discussion all day. I'm going to move on. I'm going to go ahead and set up my little timing indicator on the engine real quick. Right now my engine is set to top dead center on my degree wheel. It's right on the 0 mark. You can see clearly this marking on my rotor isn't going to work. It's way over here when my 0 is over here. So I am just going to make a mark myself. Try to be as careful as possible to get that to line up. Right here on my rotor. That way I can check the timing using it. One nice thing about a degree wheel versus any of the other methods though for setting this up is that since I've done this myself, I can double check my markings by checking this versus my degree wheel now that both are set up. So it's not just that I can check 0, I can go to say 30-ish, get 30 on there, see if it's at 30 on there, or I can go way over here to 30. I don't know if that's lined up here. Let's see. It's 30 on this side. Looks like we're on 30 there. So you can just kind of double check everything this way. And luckily for me, everything looks pretty decent that I've checked. All I've got left to get this thing ready to run is to get my spark plug wire cut to an appropriate length and reinstalled, because you can see in stock form it's way too long for the short reach that I've got to my plug here. And they're real simple, these solid copper core wires. Just use a decent cutter and you can chop them down to length. So I'm going to install the boot loosely on here just to give me an idea of where I want it. And I need nearly no wire. I'll make mine a little bit longer. That way I've got some to cut off if it gets a little scraggly at the ends or something, if I have to replace either end of that. But I'm just going to cut it probably only 4 or 5 inches long here. Cut into the wire, screws right here into the coil. Give it a tug, make sure it's secure. To finish up, just got to install the plug boot on here and hopefully hear a little snap to know that it is secure in place. There it goes. Real quick note, when you cut your spark plug wire down, if you've got to cut it down, save the excess if you've got much left, because you can actually use this to make a new spark plug wire for this or for something else if you need to. And you can buy replacement caps as well. I like these NGK caps. This is an LB05EP, and that is the terminal nut style. I like those for this kind of engine, so don't throw that stuff away. Anyhow, engine's back in. I've got all the ignition system stuff hooked up. I'm missing some hoses for the coolant system and such. Obviously I can't run a water pump because I'm going to check the timing. But for the most part I should be about ready to go toward the next step. Next step will probably be basically firing this thing up and doing some tests on it, which I hope to show you in probably the next TPR 86cc update. So make sure you're subscribed if you're not already. Thanks for watching, and please like the video if you enjoyed it or found it helpful.